Right, good afternoon, all, and welcome to our session, Mastering Intelligent Query Processing in 20 Minutes. So today we are going to dive into an exciting world of query optimization and performance improvement without you doing much. So it's all built in. I'm Manish Kumar, Senior Cloud Solution Architect with Microsoft, and he's my colleague.
And I'm Haider, Senior Cloud Solution Architect, Microsoft. Today, we are going to talk about intelligent query processing. I hope you can hear me okay. My children always complain that they can't hear me. So I hope you can hear me. So what is so intelligent about it? What does intelligent mean? Intelligent is kind of loaded word. It means different thing to different situation. But in SQL engine term, it means it learns. So that's the main thing. It learns, it changes things dynamically when it's needed, and then it learns again. So that's the main thing about intelligent query processing. It was introduced in 2017, SQL Server 2017, and it has been being enhanced all the way until now. And we'll talk about detail on what are those enhancements are. And it's part of the SQL engine. So wherever SQL is there, whether it's SQL Management Instance, SQL DB, SQL on VM, SQL on-prem, it's there everywhere. And the whole idea is to improve the performance. That's what the target is for this. And the way it works is it learns, as I said, it learns from your execution plan, but there is no algorithm, which is, we haven't trained it from outside data. So we haven't used anybody else's data. It's always use your own data to learn it, the way you execute your query, how the execution plan look like, how the weight stacks it. Based on those execution and the way you run your query over a period of time, it learns and then it suggests, provide the feedback. We'll go on detail those feedback. But enhancing, I'm looking at the wrong, enhancing query performance, the key objective, there are lots of points there, but I think the key objective is to find a way where you don't need to do anything. You don't need to take action. It learns and improve the performance, okay? You can always go and change it. If you don't want feedback, you can switch it off. So nobody is force you to do that. But one of the things is the core of all these smart intelligence processing is the query store. So the query store is there for quite some time. I think it was introduced in 2016. And the way it has been being used is capture the history of the queries, runtime and statistics, how the other metrics doing, and store that information. Okay, and before 2022, you have to manually enable it. So it was not enabled by default. In 2022, we have enabled it by default. Okay, so it's there unless you want to disable it, you can disable it, but it's there by default. And another good thing about it now in 2022 is support read replica. Okay, and what does it mean? That before that, if you have got a read-only replica, the intelligence is gathered from the primary only, not from secondary. And in the practical situation, read-only replica will have completely different set of queries being running. Even though data might be similar, but different set of queries being run, and that's why in 2022 it supports read-only replica as well. So that means you have got two set of query store on primary and secondary, and is doing its job behind the scene. And its IQP is not just one feature, it's a suite of features. And the suite of features was introduced in 2017 and is being enhanced all the way. So added more feature in 2019 and 2022, but at the same time, we are enhancing all those features which were added in 2017. So that's yes. Another thing I want to highlight is that, so far we were collecting all those information and metrics in Query Store, and you take the action. Now what we are doing is based on all those intelligence, its engine determined what the right optimize. How do you optimize it? What the right optimization pattern for you would be. So it does is the Query Store is now being used in a different way, in a more intelligent way. So that's the Query Store. I'll hand over to Manish to the next one.
Right. So SQL Server 2017 actually marked an exciting milestone by introducing adaptive query processing. So yes, it came as an adaptive query processing. It was not called IQP or intelligent query processing when it came in 2017. There were 3 great features which were launched: adaptive joins, interleaved execution, and query processing, the memory grant feedback. Now, adaptive joins actually chooses the right join based on the runtime stats. So on the fly, it comes up and changes the join based on the runtime stats if it feels so. Interleaved execution is for MSTVFs, multi-statement table-valued functions, to improve the performance of those. We'll go into some detail into that. And memory grant feedback is granting a feedback on the actual memory used than the granted. So when you compile the query, a memory has been granted to the query for the execution. When the query gets executed, then what is the actually memory used, and that feedback goes back. So we'll see that as well. In 2019, again, a plethora of features came in, which you can see in white boxes. And that is when the intelligent query processing name was branded or coined in. And then this advanced adaptive query processing became a part of that tree, or the family tree. And the family grew like that. Okay, so quite a few good features again came in, like table variables, deferred compilation, that aims to improve the performance of those queries or statement which has a table variables. Batch mode for row store, scalar UDF, user-defined functions. Once you're using a user-defined function, the query slows down a lot, isn't it? So this feature helps that to improve your performance of those queries which uses EODF. Again, there was an improvement which came in the memory grant feedback, which used to be a batch mode. Now they have introduced the row mode as well in 2019. And then further advancements came in SQL Server 2022. The one in the dark blue, you can see. Again, the memory grant feedback enhanced. Few really, really good ones came, which probably if you have been working as a DB or have worked on performance optimization, you'll understand parameter sniffing, it's a big pain, always. It has been. So that is the one parameter sensitive plan optimization that helps you with that. Again, cardinality estimation is an absolute must to be right. If the data is skewed, that means your performance is going to go down. So cardinality estimate feedback is the new one which came in SQL 2022. Degree of parallelism, unnecessary, lot of queries gets parallel, which because we have a DOP setting on the server level or we provide a hint, but that is something which a human has done. This is going to be looking at this query and okay, it's been distributed, DOP has been used like 8, not optimal, let's reduce it for the next execution, something like that. So that again came in SQL Server 2022. So because this is a small 20-minute session and to respect the time, we can't actually go into each and every one into some details. So what we have done is we have handpicked 5 of our favorites, which we think, which has been a problematic in our past, and that's what we think that let's discuss those 5. And we'll start with the memory grant feedback. I do love this memory grant feedback. It came in SQL Server 2017 as a batch mode, got enhanced in 2019, extended to the row mode as well. Now, when you execute a query or when you compile a query, Optimizer actually, based on the resources that's going to be used, Optimizer goes and allocates some memory to that plan. And when the actual execution happens, if the allocated memory is way less, there is a risk that it will or it may spill to the disk. And if that spills to the disk, it's going to be a absolutely havoc performance of your query. If you're granting more memory, then you're wasting the memory first, which reduces the concurrency. So exact or more accurate memory grant is absolutely must, and this is what came in SQL Server 2017 for the batch mode, extended to the row mode in 2019. But one thing, what happens is when you actually execute the query, Optimizer goes and sees that, okay, this query ran and it took this much of memory, and it used to go in and update that execution plan in the cache, saying that, okay, this memory was used. Next execution, it looks at the exact memory location, and then that is what is allocated to the next time when the query executes. Now, what happens if the plan goes out of the cache? Which happens, if it fails over to the secondary node, or you restart the server, or the cache is full and the memory and the plan goes out. What happens? All that intelligence which has been built is gone. So 2022 brought a great thing that it started persisting it in the query store, provided query store is enabled. If not, it will not. Okay, it's not going to impact you or start giving some error. It won't. So you'll be losing at that. If query store is enabled, it goes and starts putting it into there with that query plan details and the memory which was used. If the plan goes out of the cache or restarted, next time when the same query executes, it goes and gets the data from the query plan and runs. Okay, so once that intelligence has been generated, stored, you can use it later as well. The other thing which in SQL 2617 and 18 was that it used to look at the last execution and the memory used, and then use that same memory in the next execution. Right. What happens if there is a parameterized query? When the parameter comes, and based on the parameter, the number of records or the cardinality changes. Memory requirement changes there, isn't it? So calculation got changed, and now we put a percentile-based calculation, which actually goes and looks at the near history of the executions of that query, and then says that, okay, in the near history, it has run 5 times, 10 times, and this is the query, memory being used, whatever the variety is, and then comes back with the right memory settings, and that is what goes into the query store, and your execution comes back. So that covers all the query, not only the normal one, but the parameterized one as well. The next one is interleaved execution. Again, I would love this because in my DBA days, I used to be a DBA long back. This was a one which always troubled me whenever there was a statement using a multi-statement table valued function. SQL Server 2014, 2016, we used to take a fixed cardinality of 100. That's it. And SQL Server 12 and before, a fixed cardinality of 1. What happens if 500,000 rows come with 100 rows as a cardinality? So your performance goes down. Okay, so interleaved execution started, and the aim is to improve the those queries performance which uses MSTVFs. What it does is it starts compiling the query, and then when it finds that, okay, there is a multi-table function, it goes and executes that, get an exact cardinality, estimates, comes back, completes the compilation, and that's the query plan. So you get an exact query plan, and that with an exact query plan and with 100 cardinality estimate, you can understand the difference. So I'll show one of the query plans here, which doesn't use interleaved execution. Either it has been switched off or it's not a SQL Server 2017 with compat level 140. What happens, if you see the purple arrow, it shows 100 rows, while the rows are 527,000 rows. What happened next? It chooses nested loop join. Nested loop join you must be aware that a nested loop join actually fits well with the small quantity of data. So optimizer thought that let's use this because the number of records which is going to be processed is only 100, right? So nested loop join comes in, and what happens here? You can see a small, I don't know whether you can see, but there is a small yellow mark which shows that, yeah, which shows that it may spill to the disk. That's the problem, isn't it? Now, interleaved execution, what it does.
No. No, go back.
Sorry. Yeah, this is the next one, which uses interleaved execution. Right number of rows selected, right number of joins selected, hash match join, right? It was nested loop before, it's hash match now, better join. And if you see, there is no spill coming in the tree. So that improved itself. You don't have to do anything. Absolutely, as a user, as a DBA, as a user, you did not do anything. This is something which I have struggled in my past. You are not going to struggle anymore because there is an absolutely amazing feature which works for you. One more is adaptive join, which is again my favorite. We did touch about the nested loop and hash match. So this actually works between nested loop and hash match. What join a optimizer is going to choose depends upon the stats and the cardinality estimate. If the data is skewed, it will go with the smaller one. So if an optimizer thinks, I'll take an example, if you run a query, optimizer thinks that, okay, it's going to process 500 records, that's fine, let's go with a nested loop join. When it starts running, okay, 500,000 rows are coming because the cardinality estimate is not correct because the stats have not been updated or whatever the reason is. What happens then? On the fly, adaptive join will actually go and change that nested loop join to the to the hash match, and your query performance starts getting better. On the fly, not for the next one, at the same time. Okay, so next is parameter-sensitive plan optimization, which Heather is going to cover.
Hi. Okay, I've got a little less time, so I will try to finish as quickly as I can. So query store need to be enabled for this in a read-write state. Okay, and parameter-sensitive plan optimization is especially useful for when your data is not distributed evenly. Okay, especially for analytical queries, where the huge amount of data is involved. And generally what happened that when the parameter is there, it caches the execution plan so that it can use the same execution plan for the next query. But the problem is that because the data is not evenly distributed, if it uses the same execution plan, it's not going to perform. So what does it do is, there are a few terms which I would like to highlight here. You will hear dispatcher expression, which is basically evaluate the cardinality of predicates as the query execute, and based on the runtime value of the parameter. It's identify what the runtime parameter value is, and then transfer the execution to the dispatcher plan. And the dispatcher plan is nothing but is a collection of predicates. So what this feature would do is that if it see that the data is unevenly distributed, so it picks up three parameter value, which is going to perform really worse, or data. If you look at the example, agent ID 1 has got only 20 listing, whereas agent ID 2 is more than 70,000, and 3 is in a million. So they identify everything, 3 different parameter value or range, and put together a child query. So based on the value which is skewed across, it's identified that, okay, I wanted to have 3 different values, okay, and for all those, there are 3 different, what we call a query variant, which is child query. So for all of those parameters, it creates 3 execution plan. When you hit a query, with a specific parameter on the range, it will go and execute the right child query. So that's why the performance improved. And finally, very quickly, the degree of parallelism is, again, it's been a pain because you can't manually set it and test it. It's a big pain, and that's why the way it works is that when you set up a DOP of say 32, query execution plan, what it will say that this feature would check it and say, okay, I wanted to reduce the degree of parallelism to say if there is less wait or elapsed time. And once it's done, it finds for next several queries, if it finds it improved the performance, then it will pick this up and then it verify that this parallelism work. If not, then it will go to the one before. So this is how, when at the end of this, it's find the right DOP value. But you don't need to do anything. You don't change anything. You just define your max DOP, and it works behind the scene. So thank you very much. We have gone a little bit over time.
Yeah, sure. It's not much. We would appreciate your feedback, please, if you all can. That would be really helpful. Thanks a lot. Thanks.
And we are around, so if you have any questions,
any questions, we can take there on the Microsoft booth. We are there for next 10, 15, 20 minutes. Please, if you have any questions, we don't want to block this room, but we are there. Okay, thanks a lot.
Thank you very much. Thank you.